Hello and welcome to another session of mathematics lesson. In this lesson we're going to look at variation, the second class in variation. But before that, let us go to the previous session of this subject. Welcome back. In this lesson today we'll continue with the remaining two types of variation, which are joint variation and partial variation, and then we'll go over to application of variations. So let's quickly look at joint variation. Joint variation. The mass of a sheet of metal is proportional to both the area and the thickness of the material of the metal. Therefore, M varies jointly as A and then T, where our M here is mass, and then A here is the area, where T is the thickness of the metal. So we say that the metal so we say that the mass of the metal is dependent on the area and then the thickness of that metal. Okay, and then another example is the football and air. Football and air. Without air, football is useless. When football is bought, the first thing that is done is to fill it with air. You pump your air in order for the football to be useful. Now, the air in the football determines the weight of the football and also the usefulness of the football. So invariably it means that football and air are what? Joint variables. Okay, and then the relationship now that exists between football and the air is studied under joint variation. I hope that is clear now. Okay, so let us take an example. Okay, let's solve the question on the screen. It says y varies inversely, mark the word inversely, as x squared, and x varies directly as z squared. Then find the relationship that exists between y and z, given that c is a constant. C is a constant. Okay, let us start. We will solve this question part by part. Okay, the first sentence says that y varies inversely as what? X squared. Y varies inversely as what? X squared. You remember inverse variation, and therefore we have that y is equal to a over x squared, where a is a constant. A is a constant. Okay, in our previous classes we used k, but in this lesson I want us to use a as what? A constant. Okay, so y is equal to a over x squared. Similarly, we are told that x varies directly as z squared, so we have x varying directly as what? Z squared, and this is equal to and this means that x is equal to kz squared, right? But in this example I want us to use b in place of k. Okay, so therefore x is equal to bz squared. Okay, so we've gotten our y to be equal to is equal to a over x squared, and our x is equal to bz squared. Okay, we just took them from here. Fine. So the first thing we need to do here is to substitute x equals bz squared in equation 1, and this is our equation 1. Okay, this is our equation 2. So in our equation 1, y is equal to a over what? X squared, and x is equal to bz squared. So because of the power here, we still add what? 2. Y will then be equal to a all over y will be equal to a all over, open this bracket, we have b squared z squared. Is that correct? But remember, in the question here we are told that c is given to be what? A constant. C is given to be what? A constant. So by that, a and b are also what? Constants, but can be replaced by what? C. So therefore we have y to be equal to c all over z raised to power 4. This is 4 because of z raised to power 2 times 2 will give us what? Z raised to power 4. So it was a mistake. Okay, so we have z, we have c, we have y to be equal to c all over z raised to power 4. Okay, then similarly, if we want to make c the subject of formula, c then will be equal to what? Y times what? Z raised to power 4. And that's just it. Okay,